Welcome back, Math 098. We're going to continue with this keep, switch, flip when we're dividing rational functions. So as I mentioned in the previous video, this is the third of hopefully only three, but in the second video we talked about keep, switch, flip, but I also mentioned that I like to, while flipping, also factor. So as you get a lot of practice with this, and I realize that you're really doing 4 problems in one. For instance, if you're not very good at factoring with the leading coefficients, not 1, because I can just look at this and recognize that I probably want to do 25 minus 2 to get 23. Well, how do I get 25? Well, that would be 5 times 5. Well, 5 times 2 would give me 10. I just need to have 5x times 2x. And 5 times 1 would give me 5. In order to make that negative, make this one negative, so then the outside is 25x minus 2x. So if you're not good at guessing and checking, this is going to take you some time. So don't get me wrong. And the same thing with the next one. As I'm looking at this, I would probably do, 50 plus 1 would give me that 51. Well, how do I get 51 then? Well, 5 times 10 would give me 50. Make it a negative, so it's negative 50, and then a negative 1 to give me negative 51. And you could double check that this is right. And I realize it might just take you longer. So I'm switching this to a multiplication, so I have to flip these, and while I flip, I also want to factor. I'll just stick with the same colors, because as I'm looking at the top, this is going to end up in the bottom, and the math might not be that easy for you, but when you factor, there's only one way to get 2x squared, that's 2x times x. And getting 10, there's 2 different ways, but it makes sense to do 4 plus 5 to get that factored. And then the same thing with the bottom is there's only one way to get 7x squared, that's 7x times x. And there's a couple different ways of getting 20, but it's probably like 10 times 2, because then if I put a 10 right here and make it negative, that would be negative 70 plus 2 will give me negative 68. So guessing and checking will go a long way for you. Otherwise, you basically have 4 problems from chapter 5 all in one. And then the whole premise is then to identify that there's a 5x minus 1 on top and bottom. There's a 2x plus 5 on top and bottom. There's an x minus 10 on top and bottom. So your final answer is 7x plus 2 all over x plus 2. A much easier answer, simplification. That's why we call it simplified. It's a simplified version of the original problem. And you can probably understand why somebody might look at this and say, okay, you don't have to go through and say that x can't be 1/5 or 10 or negative 5 halves or negative 2, or you also have to mention this one because at one point it was in the denominator, negative 2/7. You can see why the book forgives you for not writing the domain down. So here's another one where there's a lot going on, and I recognize that. Now, the one thing to mention is that when you have a multiplication, don't mess with that. So what I would do is factor that x squared minus 16, that's x plus 4, x minus 4, that's a difference of squares. And then the next one, you can do a greatest common factor there. So factor out a 5, and you'd be left with x minus 4. And now we have to flip this one because of the division. You only flip the divided by ones. So there's going to be an x on top. So as you look in the bottom, don't forget that x minus 4 squared means that there's x minus 4 twice. I'll just write the 3 in front. I don't know if that really bothers anybody. You also have that x. But then as I flip this, I want to factor. Well, think about factors of negative 12 that add to be 1. That's going to be x plus 4, x minus 3. And now the canceling fun begins, if you want to call it fun. We have an x plus 4 on top and bottom, x minus 4 on top and bottom. There's two x minus 4s on top and bottom, and x on top and bottom. So the best answer on this one is 5 over 3 times the quantity of x minus 3. And if you want to, you could distribute that 3 into the denominator, but you don't have to. Again, a better math teacher would say, make sure you write down all the values that were in the denominator that would make dividing by 0. Again, I'm not going to expect you to do this, but these would be all the values. And I just want to be a good teacher. I want to make sure I'm explaining everything to you. And then the very last one is getting you to, it is a rational expression because you have a function over a function. It's a ratio, but getting you just to understand, I guess, a word problem. And I think this is a stretch as far as anything we're trying to do, because all I would do is, because we're trying to find the company's cost per t-shirt. Well, X stands for the number of t-shirts. So all I would do is plug in 100 in for X and then solve, 1,000 in for X and then solve. And if you want to, you can just use a graphing calculator like Desmos. Yeah, let's just do that. So I just went ahead and did the problem already. And there's several ways that you can actually get the correct answer. One way is just to write X equals 100. You might want to just double check that you type it in correctly. Like at first time I did it, I think I only put 1,000 down, but it's supposed to be 10,000. But the cost of making 100 shirts was $102.60. And then, well, the other way I was going to show you is, well, you'd have to zoom. You'd have to go all the way to the right to get this 12.6. The other way I was going to show you, just like I mentioned before, you can make a table, and then you can just jump down here and put 100 shirts, and then 1,000 shirts. So this is the cost per shirt. So the more shirts you make, the less per shirt it would cost, which is why it's a ratio. It's a rational function, is because it's a rate that you're finding. So 102.6 and 12.6. Yeah. Which may seem counterintuitive, but it does make sense that the more shirts you make, the less the cost is per shirt. And the less shirts you make, the more expensive it is, because I imagine there's a cost for the machine just to run the machine. So I realize this is 3 videos long, so hopefully you stuck with me. I tried to assign the odds so you have a reference in the back of the book, and you also have Desmos to check with a graphing calculator if you had the right answers.